Okay, here's a quick solution to one of the homework problems that I assigned for you to turn in, homework problem number 1 from the circuits assignment number 1. Okay, so what you're supposed to do here is find the power associated with every element, and I said to use an equivalent circuit approach. Okay, so we're looking at this and we're thinking, how can I make this circuit more simple so it's easier to solve? It has 2 loops. Could I collapse this down into a single loop where it's really easy to get something, one of the currents or one of the voltages or whatever in the circuit? All right, so when I look at this, what I'm seeing is that it's fairly obvious to me that the 105 and the 140 are in parallel. Okay, so if you think about it, they have to have the same voltage across them because there's no other elements in that loop. So that's the definition of 2 things being in parallel. All right, so we can calculate 105 in parallel with 140. And if you recall, there's a formula for that involves reciprocals, but you can also, if you take these pairwise, just do 105 times 140 divided by 105 plus 140. And that gives you the parallel resistance, which in this case is 60 ohms. All right, so at that point, I have an equivalent circuit that looks like this, where the 10 stays, the 30 stays, but the parallel combination gets combined into one single resistor. And now this is just a single loop circuit. Okay, and we can break that down further and come up with a single resistor circuit, because all these have the same current flowing through them. They're in series. Okay, so you add resistors in series, so 10 plus 60 plus 30 gives you 100 ohms. Alright, from there I can write a KVL equation around the loop. So if I start here and move in this circle, I would see that I have a rise of 100 volts, and then the drop across this resistor is just from Ohm's law. That would be I times 100. Okay, so that tells me that I is 1 amp. Alright, so from there we can start finding the power associated with various elements in the circuit. We can start with a source. Here's a 100 volt source, and I know that I have 1 amp moving in the direction of a voltage rise. Okay, so this is the active sign convention. Okay, so what that tells me is that if I'm looking at the power associated with that 100 volt source, it's V times I. So 100 times 1 gives me 100 watts, and because it's the active sign convention and I get a positive number, I know this is power supplied to the circuit. Okay, then I can move up to the second, or actually it would be the first equivalent circuit that we did. All right, so if I move to here, I now know the current moving through the 10 ohm resistor and through the 30 ohm resistor. We know that's 1 amp, so I can calculate those powers as well from the equivalent circuit. Okay, so it's I squared times R. That's one of the formulas for power. So I know that's 10 watts. It's a resistor, so we know it's used. Okay, and if you think about it, it's the passive sign convention, so all that's still consistent. Okay, and then the same thing applies for the 30 ohm resistor. I squared times R is 30 watts used. And then when we get to the original circuit, we need the power associated with the 105 ohm element and the 140 ohm element. And so what we do there is we say, well, if I had this voltage, if I had the voltage across that parallel combination, I could use the V squared divided by R formula to get the power for each of the resistors. Okay, so I go here and I say, well, if I wanted this voltage, the part in red, this voltage, where is that on one of my equivalent circuits? Well, I can't use this one because those two resistors got absorbed in, and I'll lose those points in the circuit. But between here and here, and that's these 2 points, I know this is the equivalent voltage that shows up in the first equivalent circuit. Okay, so that voltage would be V times I is 1 amp, so this is 60 volts. And so I know this is 60 volts here. So both these resistors have 60 volts across them. Okay, so that lets me calculate the power. Alright, the power in the 105 ohm resistor is 60 squared divided by 105, which turns out to be 34.3 watts. And it's a resistor, so it's used. And then the power for the 140 ohm resistor is 60 squared over 140, which is 25.7 watts used. Alright, so that's how to walk your way through finding the power associated with a simple circuit by using an equivalent circuit approach.